That subscript is a number which specifies the location of an element in an array. If it is of one subscript, then that is one dimension. Then why we are going to use the subscript? To access the element, to get to know the location or a position of an element in the collection of elements. In order to represent the size of an array, you must use this square bracket. Within that, if I am writing 5, then it will be able to store only 5 elements and index will going to be starts by 0. Very important question. Hello everybody, a warm welcome to one and all. Welcome back to the first session of Chapter 2 of Unit 1, and we are learning with our B.C.A. second semester subject called Data Structures using C. I am Rohini T.S., Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So as we all know that as per the NAP syllabus of the Chapter 2 of Unit 1, the concept is all about this arrays. I will be discussing about arrays in my today's session onwards. So here in our today's session, we will be learning regarding the arrays. That means what do you mean by array? What is the need of having this array and what are the types of arrays we have? So I will be discussing regarding the types of arrays. So mainly it is of 3 types and you will get to know in this session what are the types of arrays that we have. Along with that, let me tell you regarding the declaration of that type along with the initialization. This is what I will be discussing in my today's session. Let me get into the session that is with respect to arrays. So till now we got to know the basics data structure, isn't it? And we will be understanding, or we got to know regarding what are the classification of data structure and how each data structure will going to work. So under that we have a primitive, non-primitive. So in the non-primitive again we have a linear and non-linear. Under the linear data structure or a linear primitive data structure, there we have this arrays concept, right? So now we'll see what do you mean by an array here. So that an array is an ordered collection of elements of same data type that share common name. So here you need to remember 2 keywords, right? One is of what? It's of same data type. Already know about the data type that specifies the type of a data. It can be integer, float, real, or it can be boolean. So those are all the data type. Float, char, all those are the data types. So when I have a collection of elements, in that we are saying that as an ordered collection of element, it's not jumbled, it is not unordered, it's of order collection of elements and which will going to be having the same data type. For example, if I have 10, 20, 35, 35.4, will it be a same kind of data? No, because I'm mixing whole numbers with the fraction numbers. So that can't be same values or a same type of data. So that when we are calling this as an array, it will be an ordered collection of elements of a same data type. For example, 10, 20, 30, 40. So all those are the whole numbers that comes under integer data type. So we can say that as a ordered collection of elements of a same data type that share a common name. For example, if I call A as a name of an array, under that I will be storing some collection of elements. Then I can get to know this element belongs to this array. So any number of elements I can have, but all the elements will going to belongs to a same name, or it will going to share a same name or a common name in order to represent that element in the collection of elements. That kind of process is called what? An array. So it's an ordered collection of elements of same data type that share a common name. Then how elements will going to be arranged in an array? We'll see here, arranged one after another in adjacent memory location. Adjacent in the sense one after another. As I told earlier, if I am taking 10, 20, 30, 40. So here, how the elements are arranging? One after another. So it will be in the linear data structure. That's why we got this array concept under the non-primitive. Under that we have a linear data structure. So in that data structure, array is the one of the example. Already know about the linear data structure, right? So in that, elements will going to be stored one after another. So these elements are accessed by numbers called subscript. Then how can I access? How can I get the benefit from all these elements? I wanted to access it. I wanted to get to know the value of it. Then how we are going to do that? That too with the help of certain numbers. That numbers we are going to call that as a subscript, or it will be considered as what? Indices. So it's a what? Plural of index. So how can I get to know the position, or how can I get to know where you are living? Just by knowing the location, right? So just by knowing the door number, flat number, anything it can be. So here also we are going to access the elements of an array with the help of its subscript. That subscript is a number which specifies the location of an element in an array. For example, here I have 4 elements, isn't it? 10, 20, 30, 40. But what if I have 1000 number of elements? How can I get to know where 50 is locating, where 95 is locating? So in order to get to know its position, we are going to use certain numbers. That numbers is called subscript. So here, what is the name of an array? A. So, and its subscript starts with 0. Always subscript will going to starts with 0. Location or indices will starts with 0. And it needs to be a positive number always. It can't be -1, -2, nothing like that. It has to be always positive number, and the minimum index or a first index of an array specifies the base address. So we are going to call this as a base address. That gives you this address of the first element. If I get to know the address of first element, then it will be easy for me to get to know the address of further elements. Why? Because all the elements will going to be stored in the adjacent memory. It won't be skipped, or it won't be somewhere else. So it will be one after another. That's why finding the base address will be important. If I get to know the address of first element of an array, then it will be easy to get to know the address of further element as well. So here, and I will taking a of 1, and this specifies a of 2, and this specifies a of 3, right? So then, what is the location of an element called 40? That is 3. What is the location of an element called 20? That is 1. So how we are going to access the elements of an array? That too by some numbers. That numbers needs to be always positive and should start with 0. First index or first subscript of an array is always 0. Right? So here the elements will going to be accessed using subscript. That is what the reason we can also call this array as a subscripted variables. We are going to call the arrays as a subscripted variables, isn't it? So these are the basic definition and basic things that you need to learn about the arrays. What is the definition of array? How this will going to be what accessed or fetch the element, how the elements has been stored one after another in adjacent memory location, and also we are going to use subscript or indices in order to fetch the elements of a collection of elements. And also one more thing here, ordered collection of same data type. If it is of collection of same data type, then we can call that as a homogeneous elements. So homogeneous elements, that means it's of same kind. Homogeneous elements. For example, if I am storing A, B, C. All these are the character data type I am storing, right? After that, if I am storing 10.5 and 2.3, this is also one of the same element, collection of element. Why? Because these two are the float numbers. And also if I wanted to store A here 10.7 and 19. Can I consider this as a collection of elements which belongs to an array? No. Why? Because it's not of a same data type. First I have a char, then I have a float, at the later I have the integer. So it can't be considered as an array. If I wanted to consider an array, then it must be a ordered collection of elements of a same data type. So if it is of same data type and if it is of n number of elements, though we can call that as an array. These are the basic things that you need to understand. Then what are the types of arrays we have? So totally we have 3 types of arrays in that. First one is one-dimensional array. In short, it is 1D. Next we have a two-dimensional array. In short, that is 2D. Here D represents the dimension. If it is of one subscript, that means square bracket. If it is of one subscript, then that is one dimension. Then why we are going to use the subscript? To access the element, to get to know the location or a position of an element in the collection of elements, right? So here also we have a two-dimensional array and also we have a multi-dimensional. So if any array size which is greater than 2 dimension, then everything will be considered this multi-dimensional array. And also I can consider this as ND, or it can be any number of subscript which is greater than 2. If it is of 2 subscript, then that is two-dimensional array, and here if it is greater than 2 subscript, then everything comes under this multi-dimensional array. So in our today's session, we are going to have the brief discussion regarding this one-dimensional array, or in short it is 1D. We'll see. Fine. So here we have a one-dimensional array. So as we all know that we have an array and we know the definition of array and how we are going to access an array, everything that we know. So now what about this one dimension? So it has only one subscript. So if it is only one subscript, then we are going to fetch the elements one after another with the help of that index or a subscript. It is an array in which each element is accessed by, how we are accessing? By using only one subscript. Very, very important definition, right? So if I am accessing the content of an array, or if I am accessing the element of an array with the help of only one subscript or an index, or with the help of this, we can call that as a one-dimensional array. So there only one subscript will going to be there. And what that subscript represent? That represents the position of the element in an array. That represents the position. So for example, if I have 1000 elements of same data type, at the time I wanted to know the position of some element, then how can I get to know what is its position or a location? That too with the help of one subscript. That subscript always represents the position or a location of an element in an array. So here an array with only one row or column, it is of vector. It can't be row and column together. It can be either row or it can be column. It can't be two together. So that an array with only one row or column is called one-dimensional array. It's of vector. It can be row. If I have 50 elements, all elements will going to be shown one after another in the row wise format. If I am representing that in the column wise, at the time all the 50 elements will going to be shown in the one by one manner. So here it can be either row or a column, then that will be considered as what? One-dimensional array. And moreover, it is a finite collection of n numbers of elements of same type of that. So here finite, we are representing finite. It can't be an infinite collection of elements. It must end with certain numbers. If n value is 5, then it can have only 5 numbers or 5 elements for that collection of elements. If it is of 15, then only 15 elements. If it is of 150, again 150 elements can be there. Then how can I get to know this is one-dimensional array? So elements are stored in contiguous location. Contiguous in the sense one after another. And also elements can be referred by indexing. How can I get to know its position? With the help of subscript or indexing. So indexing represents the position or a location of an element in an array. These are the basic definition and basic things which you need to remember with respect to one-dimensional array. We'll see how we are going to declare that one-dimensional array. If I wanted to use it, first it needs to be declared. Then how we are going to do the declaration? For that we have a syntax, right? So what is that syntax in order to declare one-dimensional array? We'll see here. First it includes data type. That I need to specify what kind of data I am storing, what will be the collection of elements of which data type, in order to show that we have a data type here. Then we all have name, right? Mainly in order to represent ourselves, to identify ourselves, we all have name. In the same way, I wanted to give the value or a name for the array. That is what? Array name. So with the help of a name of an array, we can find out. And also we have a size. So here size or a subscript will going to be represented within the pair of square brackets. So here you should not use parentheses, you should not use flower braces. In order to represent the size of an array, you must use this square bracket. Within that, if I am writing 5, then it will be able to store only 5 elements and index will going to be starts by 0. Very important question. So you can see that how many subscript I have here? That is only 1. If I have only 1 subscript for an array, then we are going to call that as a one-dimensional array, right? So here what data type represent? The type of value it will going to store, and data type can be integer, char, float. Fine. Then we have a array name. Why we require array name? Mainly to identify the array. For example, in my program, if I have n numbers of array, then how can I get to know which array I wanted to use or which elements of which array I have to fetch? Then it's necessary to specify the name of an array. So that's why array name should be there, and size, the maximum number of elements that array can hold. As I told earlier, if it is of int a of 5, then it will be able to store only 5 elements, at most 5 elements, not greater than that. So let me write one example. What is the data type? Int. So here I have taken int, char, float, whichever you wanted to take. Let me consider int. Okay, and I wanted to give a name for an array. Let me consider the name as a. Okay, you can also take your name, and but wherever you are using that array should be the same name. Int is a data type and a is the name of an array, and size I am going to represent that within the square bracket. This is how. Then at last, don't forget to put the semicolon to terminate that declaration. So int is a data type, a is the name of an array, and 3 is the maximum size. What it means? This array called A can hold at most 3 elements, not greater than that. For example, if I have 10, 20, 30. Okay. How we are going to represent? Either it can be in the terms of row or a column. Fine. And here I am using row methodology, and name of an array is A. Fine. And what is the first location of first element? That is A of 0. And here it is A of 1. Here A of 2. Right. What is the position of an element called 30? That is 2. It's in the second position, and index starts with a 0, and always it needs to be positive number. And already I told you it will going to be stored in the contiguous memory allocation. One by one it will going to store, and here 1003, 1005, it will goes on like that. Fine. So this is how we are going to declare one-dimensional array. So now we have declared. Then how it will be represented here, that you can see here. It can be row-wise or a column-wise. Fine. So to make you understand this one, let me write it or rewrite it in another format. So how many elements I have here? 5. Fine. I have 5. Let me take in the terms of row 1, 2, 3, 4, 5. What is the first element? A, B, C, D, E. If I look into this one, you must be able to understand which data type we are using. Fine. So which data type? That is char. And what is the name of an array here? We can use A, or else you just make it as small a in order to make a difference between the value or a content called A along with the name of a array. So let me consider this as a small a instead of this capital A. Fine. So now what it will be? Let me rewrite it. A of 0, and it will be A of 1, it will be A of 2, and A of 3, and it will be A of 4. And always you need to remember the size of an array, the maximum size of an array is always n minus 1. N minus 1. The size of an array is always n minus 1. N in the sense number of elements. How many elements I have? 5 minus 1. So that it will be 4. At most it can store only up to 4th location, but it will start with 0. But the maximum will be 4. And you understood. So here what data type I am taking? Char. And what is the name of an array? A. And what is the size? 5. So this array called A will be able to store at most 5 elements, and all are of the data type called character. So we have used A, B, C, D, E. So here what is the name of an array? Small letter A. Then it will be A of 0, A of 1, and here it will be A of 2, then A of 3, and we have A of 4. Fine. Then what is the memory location? Here it will be 1000, 1001, 1002, and here we have 1000, 3, 1004. This is how the representation of one-dimensional array will going to look like. I hope you all understood, or else you can give any name for the name of an array. So this is what the location or a subscript, and this is a content, this is a address. Fine. So next we'll see how we are going to do the initialization of one-dimensional array. That means initialization in the sense what? When we are giving a initial value, or when we are giving a beginning value, or if we are assigning some value to the array, we are going to call that as initialization. So when we are declaring it, at that time explicitly I am giving some values to the array, then we can call that as a initialization. Then what are the methods we can use in order to initialize? You can see here. So you can give values to each array element when the array is first defined. So when I am defining an array, how we are going to define it or to declare it? Data type, name of an array, within a single subscript, I need to specify the size, right? So int is a data type here, and A is a name of an array, and size is 5. At most how many elements it can hold? 5, right? So which are those elements? I am using assignment operator, that is what? Equals. So whatever is there in the RHS, that will going to be copied, or it will be assigned to the LHS. So here how many elements I have? 9 minus 5, 6, 2, and we have 8. So 9 will be the element 1, and minus 5 will be the second element, 6 will be the third element, 2 will be the fourth, and 8 will be the fifth element. So here you can see its representation. What is the name of an array? That is A. And how many elements it has? So it has totally at most 5. And as I told earlier, its size is always n minus 1. So n is 5 minus 1. So what will be the last index? That is 4. You can write like this, or else you can represent in this manner also. Okay. So those are optional. Fine. A is the name of an array. First element, A of 0, that is the base index. Base index or address will going to hold the location of first element. Then we can get to know the further element. This is one way of initializing one-dimensional array. So then, what is the another methodology? We'll see. If there is less number of elements, so I'm going to print an application for 500 students. What if the number of students is 400? So then 500 minus 400 will be 100, right? Then that 100 number of application will be considered as what? Not will be useful. So in the same manner, when we have a less number of elements than the specified number of size, then the remaining elements will going to be filled by 0. We'll see now. So when we have a less number of elements specified than the size of the array, I'm taking 5 elements or a 5 as a size of an array, but I have only 2 elements. Then how many elements I'm left out with? 3. So those 3 elements will going to be filled by 0. Fine. So that the remaining elements are filled by 0 with by the compiler. So here you can see one of the example. Here we have a data type called float, and name of an array is weight. And what is the size that I am giving for the array called weight? That is 5. But here we have only 3 elements. As we all know that it's of float type, so I can have whole numbers along with the fractional part. What is the first value? 1.5. That will going to be stored to the first element, weight of 0. After that we have a 2.8, then 2.5. Then what can I do for another 2 elements? By the compiler, by default, that will going to be filled by 0. So here weight, and here weight of 0, 1, 2, 3, 4. Fine. So first element will be assigned to weight of 0, and second element 2.8 will be assigned to first location or a index, and 2.5 will be assigned to second index, and we don't have further what values or elements for the size. So here size is more, but the number of elements are less. So remaining value will going to be filled by 0. So if I have used integer, then it will be 0, 0. But here we are using float. That's why it will be 0.0 and 0.0. This is one of the another method to do the initialization of one-dimensional array. So then next, what is the another thing? If an array does not include an initialization, I am not initializing anything. We are not giving what initial value or a beginning value to the array. Then the array elements may contain the unexpected values. So here I am not assigning 2.5, 3.5, at that and all we are not assigning. So if you are not doing that, it will going to hold or that contains some unexpected value which will going to be assigned by the compiler itself. Then we are going to call that unexpected value or which irrelevant value as garbage values. We don't know what value, it could be any value that will going to be assigned by the compiler itself. We'll see the next point here. So when an array has an explicit initialization, so at that time what will gonna happen? Its size can be omitted. So we can leave the size when we are explicitly initializing it from the declaration. Let me make you understand regarding this point. Let me consider int a. And I am not going to specify the size. So here the square brackets whatever we have is blank. That means I am not specifying its size. So here I can consider 2, 3, 4. So what it represents by default, by just looking into the number of elements what we have, by default that size will going to be assigned to the array. So how it will be represented then again? So it will be of 3 elements, 2, 3, 4 and name of an array is A and location is 0, 1, 2. Right? This is what this point represent. What it mean? When an array has an explicit initialization. So implicitly I am not specifying the size. Explicitly I am initializing certain values or elements to the array. At the time we can omit this size at the time of its declaration. This is how the initialization declaration, and it's all about one-dimensional array. I hope you all understood. It's all about today's session. In my coming session, we're going to see about the further concept, that is with respect to two-dimensional array. In the same way, whatever we have done for the one-dimensional array definition and its declaration initialization, everything that I will be discussing with respect to two-dimensional array, and also we'll see what is this multi-dimensional array will means, and also we're going to learn about the basic operations on arrays. So what are the operations or activities that we can perform on the arrays concept, that I will be discussing in my coming session. I hope you all enjoyed and understood my today's concept. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.